Alright, good afternoon to everyone who is watching this video online. This is our final class for VC Further Maths. Today's Friday the 14th of October, and we're going to kick off with a practice exam question on matrices. But before that, just want to remind all of you about the rules for bound references. So on Teams, last night I posted a message with a link to this page, and it tells you everything that is allowed and everything that is not allowed for bound references. So you need to know that before you enter your exam, your bound reference will be checked by someone from the school, probably Mrs. Kidd or Mrs. Collett, because they know what the rules are. So please make sure, as you're preparing your bound reference, that you are following the rules listed on this webpage. If you can't find the page, it's linked on Teams. So it needs to be A4 or smaller. You need to have secure binding, so staples, glue. Go to Officeworks and get spiral binding. Make sure you can't detach anything, so no post-it notes. You shouldn't have plastic pockets. And yeah, if anything comes out of your bound reference during the exam, that's going to be bad, so don't do that. I might just ask the room, do you have any questions about your bound reference?
So
yeah?
These things will be presentation.
So let's see. So according to this, you are allowed to annotate, you're allowed to have your own index, fold pages, cut page corners, color code pages, insert dividers. And then bound references must not include removable tabs, post-it notes, or other pages of material. So I would consider those removable tabs. So yeah, don't have those.
Yeah.
Yeah. But don't take your textbook in.
No.
Okay. All right. So that's the bound reference. Please familiarize yourself with those instructions, because you don't want your bound reference taken off you before you sit your exam. I think the stress levels will go through the roof if that happens. Okay, so at the request of someone in the class, we are looking at this question. This is question 7 of the 2018 Northern Hemisphere Matrices module. So let's just take a moment to look at the information. So we've been given a transition matrix T, which tells you what happens from one month to another based on the ratings given by a customer. And we have an initial state matrix, which tells you the number of ratings of each type given in January. All right, so let's switch over to this view. This is going to be tricky. I'll have to copy it down first. So just bear with me as I copy this down. So the question we're asking is, what percentage of people are not expected to change from one month to the next? Okay, so now I've got it written down. So here's the question. Here's the transition matrix, T up the top. We've got an initial state matrix, and this is the recurrence relation telling you how one state goes from one to the next. All right. I invite participation from the audience. What do you think you would do? This is a question you could realistically get exactly 2 weeks from now. enter the transition matrix into your CAS calculator, what would you do with it? So you would calculate S1. All right. Okay, so Caitlin's put forward an idea. If you've never solved this kind of question before, it's worth paying attention to this. So I like your thinking, Caitlin, because naturally, because of this, instinctively you want to just calculate what happens in the next month, right? But there's more to it than that. We've got to read the question very carefully. So what we're interested in is, there are going to be some people, if I just go back to the question, so the ratings are poor, good, and excellent, P, G, and E. And we're saying that in the first month, some people will give a rating of poor again. Some people will give a rating that's good again, and some people will give a rating of excellent again. Right? So that is to say, they're not going to change. So let me explain to you why just calculating at the next state isn't going to be enough. So if I do that, let's say I do this. So 3 by 3 matrix. Can you see that okay? On the screen? Is that too small? Okay. All right, so this is T. All right, and then our initial state is 40, 110, and 50. So we're going with Caitlin's idea at the moment. So if we calculate S1, this is what we get. Okay. So S0 was 40, 110, and 50. And S1 is 51, 86, and 63. So based on my experience, I know that this won't be enough. But can you see why this doesn't help us answer the question just yet? So this is what we started off with. 40 people answered poor, 110 answered good, 50 answered excellent, and then in the next month, 51 answered poor, 86 answered good, and 63 answered excellent.
Is it because they changed? And we're finding that percentage doesn't change?
Yeah, so it's not clear how many people who answered poor in the first month answered poor again in the second month. Right? All I know is that the number of people who answered poor grew by 11 from the first month to the second month. So we need to look more closely at the information that's been given to us. If in doubt, start by drawing a diagram. Not because you will do this in the exam, but because you recognize sometimes a picture can be helpful. How many people are there in the poor category initially? 40? Correct. You got that from the initial state, S0. So at the beginning, we have 40 people rated P, 110 rated G, and 50 people rated E. And then you're going to get transitions between each state as well. So now that I've drawn this picture, do you have an idea what you might do? Which arrows are going to help me answer the question?
The ones that stay the same.
Yep. Okay.
And the ones that change.
I don't care about them, because I just want the ones that are not expected to change. Okay, so if I know that 20% of the people in the poor category will rate poor again next time, I just need to take 20% of that They gave it to us in decimals, so I'll use decimals, 0.2. So 0.2 times 40, that's the number of people who will rate poor again. How many people will rate good again, or G?
0.3 times 110.
That's it, because there are 110 people at the good category initially, and then 0.3 times 50. Okay, so if you do this calculation, you'll get something like that. 33 plus 15 is 48, so that's 56. And how many people are there in total? Yep, so we have to go back to the initial state. 40 plus 110 is 150. 150 plus 50 is 200. So the total number of people is 200. So the proportion, or the percentage of people who don't change, will be 56 on 200, and you convert that to a percentage, 28%. So if I go back to the exam paper, I would say it is option A. And is that what it is? Yeah. Okay. Let's take a look at the assessment report for this question. Oh, but it's NHT, so they might not be as detailed. Let's see if they have anything there. Further Maths, 2018, exam 1. Okay, so question 7. Okay, so we've done pretty much what they've asked, what they've suggested here. Yeah, that's exactly what we wrote. All right, so let's take a moment to reflect. What was difficult about this question? Like, if we couldn't answer this question initially, what did we need to know to be able to do this question? Yeah. Did it become clearer once I drew the diagram? Yeah. So remember, when you're dealing with transition matrices, every time you have a matrix, you also have a diagram with the exact same information. Okay? So as you become more experienced, you won't need to use the diagram anymore. You can just use the matrix. But if you're just starting out, draw the diagram, and that might help you. Okay? All right. Is there anything else you would like on transition matrices? Like any further questions? Doesn't have to be an exam question, it could be just some aspect of theory. All right. Simultaneous equations. Shall we do that? Okay. So this is pretty standard. So I'm just going to make up some numbers. Alright, so the most common situation is one where they give you the simultaneous equations and then you're asked to put them into matrix form and then apply some matrix method to solve them. So usually you want to write your matrix equation in this form: A x equals b, and remember, capital letters means matrices. Okay. So I guess the first question I'll ask is, what dimensions do you think we will use for these matrices? Sorry, speak up.
2 by 2.
Yep.
1 by 2.
1 by 2. 1 column, 2 rows, that's right. So 2 by 1. Yeah, so it's rows times columns to describe the order of a matrix. Alright, so A will be a 2 by 2 matrix, X will be a 2 by 1 matrix, and what about B? What size will that matrix have? Yep, that's right. Remember, the rows and columns are the same. On the inside, you use the outside matrices to determine the order. Okay. So I've set up the matrices. What am I going to put in? Maybe I'll start with the middle matrix. What should I put in there?
15 and 17.
No. 15 and 17 goes here.
Yeah, x and y.
Great. All right. And what about the matrix on the left?
2, 5, 4, and minus 3.
Excellent. Okay, so if this is something that is not clear to you, I suggest you go over matrix multiplication first. So if you understand how to multiply two matrices, you should be convinced that if I multiply these two matrices on the left, I get the equations. So for example, 2x plus 5y gives me the first row on the right, which is 15. Or 2x plus 5y equals 15, the first equation. So really, it's this. We never write this, but we're saying the first row is the same, and the second row is the same. And now I've separated this matrix here into these two matrices. Okay? So if your x and y are not in the same order in your equations, you need to put them into the same order before you construct this matrix here. So for example, if it was 3y plus 4x, let's say this letter here was y, and this letter here was x, you'd have to swap the numbers in the matrix. Okay? It's harder when you're writing here. Okay. All right, so we've set up the matrix equation. How do we solve it? Any idea? So the question is, I've set up my matrix equation, now I want to solve it. So what should I do?
Like put it back into. So would you be putting back into the normal equation of columns?
Not quite. Okay, so let's imagine we're just here at the moment, okay? if I give you two simultaneous equations and I ask you to solve them, what's your goal? When someone says solve simultaneous equations, what does that actually mean? What are you trying to do? So we put them into matrices as a way of solving the equations. But when I'm done, what will I have? Yeah, so what's the answer going to look like? If someone asks you to solve an equation, like, what are you trying to do? No? Okay. All right, maybe I'm not asking the right question. So when you solve simultaneous equations, you want to find the values of x and y that satisfy both equations at the same time. Okay? All right, so that's why we put them into matrices. Okay, so when you did Year 9 and 10 maths, you probably learned substitution, you learned elimination, and there was a lot of algebra involved. It takes one step on the CAS calculator. But we have to put it into matrix form first. All right, so I'll keep us rolling. So if AX equals B, I want to solve for the matrix in the middle, capital X. I want to find the values of X and Y. So X is going to be A minus 1, or A inverse, times B. So when I write A with a minus 1 on top, that means the matrix inverse of A. Is this ringing a bell now? Okay, so we did do this. Now, because you have technology with you in your exam, you could probably just go straight to this. Yeah. So, on your formula sheet, you are actually given the inverse of a 2 by 2 matrix. But if you have a larger matrix, you have to use your CAS calculator. Okay? So just to be instructive today, I will do it using the full steps. But I'll also show you how to do it in the CAS calculator as well. All right, so are we okay? Set up the matrix equations first. And if AX equals B, then X equals A inverse times B. So I bring this matrix to the other side, and then I take the inverse. So I take it to the minus 1. Now we need to recall how to find the inverse of a matrix. So for a 2 by 2 matrix, see formula sheet. For a larger matrix, you must use your CAS. You can't do it by hand without some additional knowledge. All right, so if I have a 2 by 2 matrix of the numbers A, B, C, and D written like this, then A inverse has a specific formula.
You switch the B and C terms as A, C, D.
So you're almost right. It's actually the other way around. So you switch D and A,
Yeah.
and you put a negative sign in front of B and C. Okay? Now, if you forget, it's on the formula sheet. Okay? And you can also just do it on your CAS as well. All right? So let's apply this formula here. So I want to find the inverse of a matrix with the numbers 2, 5, 4, and 3, and I almost forgot, you've got to divide by AD minus BC. Okay, this number here is called the determinant of the matrix. Let's just remind ourselves, something happens when this determinant is 0. if I set up a matrix equation and I find that the determinant is 0, what does that tell me? You got to think back a little while.
I know there's one that means that it's unique and one that means that it's
Yes. So which one is it? Do you remember? Anyone want to jump in? Correct. No unique solution. You do need to know that. You certainly need to know that for your exam. Okay. So let's calculate the determinant of this matrix first. So what would it be? I want to invert this matrix.
Does it have to be positive at the top left corner? So would it be 3 or minus 3? It doesn't change. Don't they swap them?
Okay, start by swapping the numbers on the main diagonal. So A and D will swap places. It doesn't matter if it's negative.
And then there's minus 5, minus 4.
Yeah?
And then calculate the determinant to be 1 over.
Mm-hmm.
Is it A times D or
A times D. So when I write two letters next to each other, it's implied that you're multiplying them together.
A?
Okay.
It would be 1 over A times D plus B times C with the reverse.
Yep.
C has a unique solution.
Yeah. So it's very easy to forget to write the determinant. So what's A times D? 2 times minus 3 is minus 6. So we'll just write this over here. 2 times minus 3, that's AD, minus B times C. So minus 5 times 4. Yep. So minus 26. So 1 over minus 26 times minus 3 minus 5 minus 4, 2.
It's minus 4 times minus 5. Oh, yeah, no.
Okay, so here, I'll circle this. Here, we've calculated the inverse matrix.
And if it's below 0, does that still mean that it has a unique solution?
Yep. So the theory says if the determinant is exactly 0, there is no unique solution. Doesn't matter if it's positive or negative.
Bubble below.
As long as it's not 0, you'll get a unique solution. Okay? So that's not 0, so we are expecting a unique solution. Okay. The last thing we need to do is create a matrix. Uh-oh. Control Z, does that work? Yes. Okay. Can you all see the CAS calculator? It's a bit... Is that better? Yeah. Okay, so if you evaluate that, you get 5 and 1. Okay, so now we've solved the linear system. Now, if you aren't asked to show your working, then you can skip this step and you can just do this. So remember how before we said that xy was the matrix inverse times 15 and 17. This time what I'll do is I'll put in the original matrix. And I'll put a power to the -1 there. And you get the same answer. Okay? So I strongly suggest that you just put this straight into your CAS calculator if you're solving a matrix system. Okay? Anything else you want to know about this? Okay, I hope that was helpful though.
Yeah. Like I think I'm fine with that bit. It's just determining what the size of the matrices in the bit start.
Yeah.
I think I'm confused about that.
All right. Well, we won't do a full example. So I'll tell you the results that you need to know in a moment. But let's just start with this. So I've created a new system. How many equations are there?
3.
Yeah, there are 3 equations. How many variables are there? Sorry. So x, y, and z are your variables.
Okay.
Okay? So what would go wrong if I tried to use a 2 by 2 matrix here?
You didn't get the right answer because what I didn't
Yeah. So this time what you want to do is you want to use a 3 by 3 matrix. So you've got 3 by 3, 3 by 1, 3 by 1.
Yes.
Okay?
So you're writing everything in its own separate matrix.
Yeah. So if I have 5 equations and 5 variables, I'll have a 5 by 5 matrix here. All the letters will go in the middle, and all the answers, that is the numbers on their own, they will go in the matrix on the right.
Yeah.
Okay?
Yeah.
Yeah, that's it. So it is not that bad. Okay.
And then you use the outside numbers to determine
Yeah. So call these matrices A, X, and B in capital letters, and just chuck this into your CAS, and you're done. This is a 3 by 3 matrix, so there's no formula given to you. You have to use your CAS calculator.
Okay.
Okay? We only made you do this on the SAC so that you could show your understanding, but in practice, inverting a 3 by 3 matrix by hand would take 20 to 30 minutes. So don't try it. Okay, what's next on the menu? We've got recursion, we've got the normal distribution. So, which one? I think we have time for both. Alright, why don't we do recursion? In a previous class, we spent a lot of time on the finance part. We didn't spend as much time on the pure abstract recursion. Okay. Let's see if I've got any questions in my hand. I think my handout was all finance. Yeah. Alright, so let's start from, reasonably early in the course. You were introduced to 2 types of sequences. One of them was called arithmetic. The other one was called geometric. So I'll write an example here. Alright, so let's look at the first sequence to start with. So sequence just means a list of numbers with a particular order. What's the pattern in this sequence here?
Adding
Adding 3 each time. So I'm guessing when you did year 11, your teacher probably did something like this above the numbers, show what was happening each time. So when you are adding the same number each time, that's called an arithmetic sequence. What about the second one? What's happening down there? That's right. Okay. When you are timesing by the same number each time, that's called a geometric sequence. Yes?
Would arithmetic also work with minusing and geometric also work with dividing?
Yes, it would. So here's one. Let's say I had 8, 6, 4, 2, 0, minus 2, and I had 120, 60, 30, 15, 7.5. You might say, oh, I'm not adding, I'm subtracting. And you might say, oh, I'm not multiplying, I'm dividing. But here's the thing, subtracting 2 is the same as adding minus 2. And dividing is the same as, sorry, I've gone ahead of myself here. Dividing by 2 is the same as multiplying by a half. Okay? So even though you're subtracting or you're dividing by the same number, that still translates into an arithmetic and geometric sequence, respectively.
But you can use dividing like this, or does it have to be times by half?
Well, when you write your recurrence relation, it actually won't matter. Okay?
So you can say divide.
Yeah. You'll see what I mean in a moment. Okay? So let's keep these sequences here. So the whole point of recursion is that we don't always have a formula for generating a term in a sequence. Sometimes we might not even be, what's it called? Focused on the actual formula for the 5th term or the 10th term or the nth term in the sequence. I just care about how to generate one term from the next. So when I have a specific rule for generating one term from the previous term, that's called recursion. Okay? And in this instance, the rule is simple, just plus 3. No matter where you are in the sequence, plus 3 to get the next number. Okay? So let's turn these into recurrence relations. So remember, a recurrence relation has 2 parts. Do you remember what they are? Well, those are the types. So now I want to turn these sequences into a formalized recurrence relation. And I need to write down 2 equations to do that. So you need to know this for your exam. It's very likely that they will ask you to write down a recurrence relation for something, probably a financial context. But of course, this is the groundwork for all that.
So what was it? Isn't it like n plus 1 equals
Great.
plus?
Yeah. So you're thinking n plus 1 and n. So that's the recursion part. Yeah. So I'll do the first one for you, in case you've forgotten. So I'm just going to call this a. I'm going to call the nth term an. So usually we start our sequences at 0. So meaning the first term. So my first term is going to be 2 here. All right. this is my first term or initial term. I need to write this down because if I tell you that the next term is generated from the previous term and then adding 3, I don't know where to start. So can you see if I only give you the second equation here, I know what the pattern is, but I don't know where to start. I could have started at 4 or 20. If I only give you this, well, my sequence is pretty useless. I've only got one term. That's no good either. So that's why you need both. And when you're asked to write down a recurrence relation in the exam, you must include both of these equations to get 1 mark. Okay? All right. What do you think you would do here for the second sequence? Yeah. Very good. So you can write 3 out the front like this. Okay? Just say that you are multiplying by 3. Okay? Let's generalize now. So in an arithmetic sequence, your recursion step will look like this. an plus 1. Your textbook uses capital V. It doesn't actually matter. It's just a name. Okay? They will say an plus d. This number d is called the common difference. And it is always the same. Okay? So if you have a point where you add a slightly different number somewhere in your sequence, it's no longer an arithmetic sequence. It's got to be the same number every single time. So here, in this example, it was plus 3 every single time. If there was one number that was different, it would no longer be an arithmetic sequence. Yeah. Okay? And if you multiply by a number capital R, and that number is also fixed and doesn't change, that's called a geometric sequence, and this number R is called the common ratio. Okay? Those are terms you'll have seen in year 11. Okay, let's make some connections to finance. In finance, you learned about 2 different types of interest. They were called simple interest and compound interest. So which one matches to which here? And why do you say that?
Because compounding rather than like it adding. It compounds basically.
Yeah, yeah. So you recalculate the amount of interest at the end of every day or month or year. So you're multiplying it by a number slightly bigger than 1 to increase it every single time. Yeah. Simple interest is calculated based on the first balance. And then you get the same payment for as long as your investment goes for, which is terrible because the longer you leave your money in a compound interest investment, the better it gets, right? Think back to the Futurama example, right? Fry becomes a billionaire after 1,000 years. He'd have nothing if it was simple interest. Okay, and obviously, just by way of reminder, you can mix the 2 as well. So you could have a situation where you have some geometric growth and some arithmetic growth as well. So for example, if R is bigger than 1 and D is bigger than 0, this could be a compound interest investment. So the compound interest would be the R part, and you also put in money, like regular deposits. Those regular deposits would be the D term. So for example, let's say I put in $1,000 into the bank. I get interest every month, but then every month I also put in my pay, like $200. The interest would be the R part, the deposits would be the D part. Okay. So there's other examples. I won't go into all of them. There's annuities. Annuities is probably the main example. Is there any others? Reducing balance loan. So a reducing balance loan, R will be positive, D would be negative. And it will be the same for an annuity as well. Okay. All right. Anything else? Yes. There's one other thing I should say. When you know that something is an arithmetic sequence, we get something for free. We not only get a nice recurrence relation, in this case I can also write down a formula for the nth term. So what I mean by that is, if I know that this is the case, that I have an arithmetic sequence, I can write down the 100th term without having to calculate everything up to the 99th term. Because if I just have this at the moment, if I want to get the 1,000,000th term, I have to calculate 999,000 terms first, and then plus 3 at the end to get the 1,000,000th term. Same thing with the geometric sequence. So there's a shortcut. And that's what we call the formula for the nth term. So does anyone remember what this is? The what? No, I think you're on the right track though. So if I know this, if I know that I've got linear growth, an plus 1 equals an plus d, I want a formula that I can use for any value of n. Put any number in. So that any number is going to be n. Yeah? Let me try to make this more concrete. $17 is so that's A0. This is A6. Sorry. A5. So what number did I have to add to 2 to get to 17? Yeah, so I've gone across 5 terms. Yes, A0 to A5. This happened to my year 11 class as well. So I'll try something different. Okay. Take a look at this. What's another way to add 3 many times? Times. Okay, so to get A5, I could plus 3 5 times. Right? Or I could add 5 times 3, which is 15. So if I say, tell me what A100 is, what's that 100th term in this sequence? Do you have to write out all 100 terms? Just add 300, right? So instead of adding 3 100 times, just add 3 times 100, which is 300. Or, and the formula will be familiar once you see it, take the first term, A0, and then take your number, which was 3 just now, and then multiply it by n. Okay, so if I relate it to this example up here, I said n was 5. So A5 would be A0, which was 2, plus 5 times 3, which gives me 2 plus 15, which gives me 17. Okay. If you didn't follow all that, you can just use the formula as well. By the way, this is not given on the formula sheet. So you'll need this in your bound reference notes, or you will need it memorized. I mean, they give you something, I think they give you this, but like it's not really clear what you would do with that. Like it's not very useful. Okay, same idea here. Let's say I wanted the 100th term in this sequence. So one thing I could do is multiply by 3 100 times. Is there an easier way to do that?
Yes.
Yeah. Okay. So notice how we went from addition to multiplication to make it easier. What do I go from multiplication to? What's the other operation that you've learned? Well, division is kind of like the opposite of multiplication, yeah? So instead of multiplying by r n times, just multiply by r to the power of n. Does this ring a bell? So remember, you see how much maths you have to know by the time you get to year 12? R to the 0 is 1. I'm actually going to teach this to my year 8 class very soon. R to the power 2 is r times r. R to the 3 is r times r times r. R to the 4 is r times r times r times r. So if I want 100 terms, I would use r to the power of 100. Okay? And that saves me from pressing enter on my calculator 100 times. I don't want to do that. Okay? So you can use this. This is hard. This is probably the most abstract part of the further maths course. And you not only need to know this, you need to be able to combine this with finance as well. So you would say, you would have to calculate capital R when you're told what the interest rate is. Okay. Do you want me to go over that as well? Okay. I think I did already in previously. So I'll just do a quick example, and then we'll do the normal distribution. Okay. Let's do a daily interest example. All right. So I invest $1,000 into the bank. The interest rate is 2% per annum, and it is compounded daily. So the question that I'm going to pose is, how much money is in the account after 90 days? And I want to focus on using recursion rather than the financial solver in this example. Okay? Now, when you sit your exam, this will be scaffolded for you. So I'll do some of that for you. So I'll say let Vn be the amount in the account after n days. So that will probably be something that's given to you. I wouldn't expect you to set that up on your own. So the first thing we want to do is set up a recurrence relation. So what's V naught going to be?
The initial value.
Yep.
That's important.
Okay. V naught's 1,000. Are we going to use a geometric or arithmetic sequence here? Yep, because there's compound interest. So I know I'm going to have something that looks like this, but it's not clear what my geometric, not common ratio is going to be. Yeah, capital R. So I already went over this last week. Maybe I'll see if the class knows. What should I use for capital R here? Yep. So I've got daily compounded interest here, and I want to calculate the amounts in the account after n days. I would expect you to know this for your exam. R over.
So interest rate divided by 52. Times.
So this?
Yeah.
Yeah. Okay, so you're on the right track. So the problem with this is this number is going to be less than 1. And if the number is less than 1, this is going to shrink. When I have a compound interest investment, I want my thing to grow. So I need to add something else to this ratio. 1 plus. Okay? Where R is the interest rate per annum, and N is the number of times interest is compounded in a year. So what value of N should I use here? 365, because interest is compounded daily. There's a lot of layers here. Okay, so the interest rate is 2%. Will I use R equals 2 or R equals 0.02? Exams in 2 weeks. Yeah, it's a 50-50 chance. So R is already in a percent. So you would use R equals 2. Okay? Alright, so 2 on 365 divided by 100. Okay, so that looks good. I've got a value for capital R now. But I've got a problem. I want V90. V90 is going to be the value of the account after 90 days. I don't want to waste time in my exam pressing enter 90 times. I'm going to lose count. So how can I avoid repeating this calculation 90 times?
Do the power.
Great. So Vn is going to be R to the n times V0. Set n equals 90. V90 will be 1 plus 2 over 365 divided by 100 to the power of what?
You just said it. I don't know.
90. I've set n equals 90. Okay. Times V0, which was 1,000. So I actually prefer doing this kind of calculation on my scientific because it's faster for me. So if you have one of these, consider bringing this to your exam as well. $1,004.94. Okay, it's not much because 2% interest is not much. So in 1 year, you would expect about $20. 90 days is about a quarter of a year, so it sort of checks out. Okay, this is a pretty challenging question. I expect it might be broken up into more than one part, so they'd probably give you this.
So that would be a multiple choice question.
Well, it could be. Yeah, but it would be one of the harder ones, I would say. But then again, you know, like, as you work through past papers, you'll see questions like this. And so as you practice more, you'll feel more comfortable. But if you're doing this for the first time today, yeah, it's gonna be hard. But once you've done something like 15 times, then yeah, it's not so hard anymore. Okay? Which is why you want to prioritize doing past papers rather than writing notes. Yes, you want to write notes as well, but focus on completing exam papers. Okay, shall we do the normal distribution to finish off?
Would I be able to still do papers that you just
Well, I can scan them.
Yeah.
Also, remember this is going on YouTube.
Yeah.
Yeah. Okay. Just making sure that I can use this piece of paper. Okay, normal distribution. Take 2. So, normal distribution calculations, you should know the basic rule. So the basic rule, first of all, is the 68, 95, 99.7% rule, which states the following. So if a population or sample is normally distributed, then approximately 68% lie 1 standard deviation from the mean, 95% lie 2 standard deviations from the mean, I'll say lie within, and with 99.7 is 3 standard deviations. And remember, a normal distribution is symmetric. So the mean is in the middle, and then you've got this bell-shaped curve on both sides. And in the last class, we constructed a picture that looks something like this. So if I have the mean in the middle, 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. One standard deviation below, 2 standard deviations below, 3 standard deviations below. Okay, so just to recap, because I think the last time we were together was Tuesday? Yeah, Tuesday. So the first result says within one standard deviation from the mean, going either way, I will have 68% of my observations. So if I split it down the middle, what will I have instead? 34%. Okay? Now, because you're allowed a bound reference, you should already have this. You don't want to be working this out during the exam. Now, because I don't have a fantastic memory, I actually just figure this out all the time. So 95% will be 47.5 one way. So you need 13.5% in the next rectangle. Then 99.7 divided by 2 is 49.85. I already had 47.5 here. So I will need 2.35%. And lastly, I know that 99.7% will lie within 3 standard deviations from the mean. So how much will be on the outside? If 99.7% is inside, right now,
0.15.
yeah, so 0.15 on one side, yeah, or 0.3%, 0.3% on both sides. Okay, so make sure, please, that you've got this diagram ready to go for your exam, so you can just read off what you need. Let's do a quick example. In fact, I can use my thing. So these are the practice questions I handed out a week ago. So maybe we'll do question G. So here we are told there are 100,000 people. The mean is 163.9 centimeters, and the standard deviation is 6.6 centimeters. We're talking here about the heights of people. The question is, how many have heights between 177.1 and 183.7 centimeters. So I might just pause here. These numbers are very, very specific, aren't they? Right? Why do you think that is? Too vague of a question? Alright. Alright, so, okay. How many standard deviations away is 177.1 from the mean? Yeah? So this one is 2 standard deviations above the mean. What about 183.7? How many standard deviations is that away from the mean? Hmm? 3. That's right. So, if I were to shade this diagram, which rectangle would it be? That's right. We are looking specifically at this region here. Okay? So do you see why I gave you the numbers 177.1 and 183.7? If I gave you any other number, you couldn't use this table, because you only know the percentages for 1, 2, and 3. Okay? So they can't give you anything else. All right? Yeah. Yeah. All right. So the textbook adds another layer on top of this. They use something called the standardized score. I've done this without using the standardized score. I'll just briefly cover this now. If you want to look into this more, feel free to do so. So the standardized score is obtained by taking the value of x, so these are your values of x here, taking away the mean, and dividing by the standard deviation. And if you do that, you'll get this. With the same probabilities as up here. Okay? Z is just the number of standard deviations you are above the mean. So if Z is negative, then you are below the mean. If Z is -2, then that means your value of X is 2 standard deviations below the mean. Okay? I do think you need to know that for the exam. I think it's fair for them to ask you what a standardized score is. So X is just the value that you've been provided with, okay? Which is something that you can compare to the mean. You could say whether it's above the mean or below the mean, and Z just tells you how many standard deviations it is away from the mean. All right, I've got 15 minutes left. This is your final chance to sneak something in. Otherwise, I might just end the recording there. No, we're good? All right. So those of you who are listening online, if I don't see you before your exam, I want to wish you all the very best. Please remember to come see me or message me on Teams if you need anything. Take care.